Welcome to the session. Greeting of the day. In today's class we are going to talk about the types of forging processes and types of extrusion processes. In previous class, in the bulk deformation process, we have seen about what are the types of rolling and types of forging and types of extrusion. These are the various available bulk deformation process to make the changing of shape or reduction. Volume will be same, but we are compressing into the plate format or thickness reduction to increase the strength factors. So those things can be done by this three: rolling, forging and the extrusion process. Now we will continue with the remaining part. Now I am coming to the next bulk deformation process of extrusion methods. What is this extrusion is going to do? We are, as usual, we are putting a material, maybe hot metal, inside the containers and we are going to press there. When it is pressing action is done, it is extruded. Before there, we have converted some thickness reduction of plates, but here we are converting into a large material converted into billets, and billets are converted into tubes, bars, round cylindricals or panels, aluminum panels, frames we have seen. Those things we are going to make, the extrusion process. It is a process by which a block of material is reduced in cross section from here, reduced in the cross section by forcing it to flow through a die orifice under high pressure. Where we are giving the pressure? This is also having types we have to see. Forward extrusions, backward extrusions, types are there we should see. So here the container, and container contains a die here, you see, a container contains a die here. And this is red color, we have putting a material which is to be extruded and we are putting inside. And I am pressing through a ramp piston action, I am pressing here. When I am pressing, what happens? It has the only chance to come other side. If you are closing here, it is going to become, length of the billet is going to become square billet. So that we have done already the forging and open die forging, closed die, that we have done. Now I need a product at the other end in terms of pipe, in terms of bar or in terms of a small panel. I have creating a holes and I am making a pressing action, and it comes through from the large diameter, it comes through a small hole what is available. Maybe 5 mm, 10 mm, what available it is there. Maybe this may be 20 mm and I need in the 5 mm bar, 20 mm bar, and extruding process is done. So this is called extruding, extending from one end to another, extruding process are done. And then here we have a die. For this example, the die is very simple. In case I have a die like this, you see, I have a die like this. What happens? The extruded material goes through this path, and the extruding material goes through this path. So two paths it can go, it means two holes are created at the output stage. So what happens here? It will be like this. When it's extruded, it will be like this. You see? The frame, the die I am creating in design, that the design comes at the other end. What design, what hole it has, accordingly it should come. So we can able to produce extrusion, or generally called as extruders. A heated billet, the term heated billet belongs to hot working. The heated billet cut from the continuous casting. Heated billet is cut from the continuous casting, means it is a continuous process. While during a red hot molten material is poured, we are taking from there to here, because otherwise we have to heat multiple times the same material. Therefore, this extrusion process are done in immediate after the casting. It is one of the next step of the casting process. It is located in the heated container. By applying the pressure by means of a ram here, applying pressure by means of a ram here, by means of ram to one end of the billet, the metal flows through the die, located at the other end. From here one end I am pushing, the die is placed at the other end and it is flowing through the die. It is flowing through the die of the container to produce a session. This is the product. A part, a cross-sectional shape of which is defined by the shape of the die. I told in the last image, the shape of the die is some design is kept. According to design, according to the hole created, the output is going to come there. I will show you the image. So likewise it will be. You see? So likewise, you see here, this is the die. I have kept this die in front. I am pressing here. The material will come through this one. Material will come through this one and this one and this one and this one. The remaining part are blocked. How it will look? It may look like this. This product, if it is coming out, in this way it should come. Some other like holes, like a panels created, strip, like it will come. So likewise we should plan what design we need. See, these are some of the design. In general, extrusion is used to produce a cylindrical bars of hollow tubes or for the starting stock of drawing rods. Cold extrusion are forged products. Most metals are hot extruded. So for the extrusion process, cold working process is not there. Because here more forces required, we need a red hot condition to change from 10 mm to 8 mm itself. But here what we are doing, we are changing from 10 mm to a small thickness of 3 mm or 5 mm. So it is much more reduced in the extrusion process than that of forging, than that of rolling process. Therefore, if we are doing the same extrusion process in the cold working treatment, it creates more force needed because it is red hot is not there. It restricts, ductility will not be there. Then we should more press, we should be pushing here. It may crack damages to the workpiece. It may cause damages to the containers. All things to be strong because workpiece is already strong. It is non-ductile material, and we want to press, we want to extrude. So those things, the cold working process will not work in the extruded. So we are going for the mostly of the hot extruding process until otherwise the material having already ductile in nature at a room temperature. So then we go for the normal cold extrusion process. Due to large amount of forces required in the extrusion, so here see large amount of force is required. Therefore, generally we prefer hot extrusions. Complex shape can be extruded from the more readily extruded metals such as aluminium, generally used for aluminium panels. It is better property are required than it may be heat treated or cold work whenever it is required. We are giving some force and naming somehow it is a stress applied over the material. Therefore, if we need good mechanical properties, after the extruded product is coming out, we can take the product and put it in the furnace, and some heat treatment can be done for stress relieving. So such things can be done to improve the mechanical properties, can be done. The reaction of the extrusion billet with the container and die results in high compressive stresses which are effective in reducing cracking of the material during the primary breakdown of the inside. Compressive stresses will be help in increasing the utilization of the extrusion in the working of the materials that are difficult to form, like a stainless steels. These are all having this ductile property. Higher it will when it is red hot, but it not in the room temperatures. Nickel based alloys and other high temperature materials. So such things. we have seen up to now the hot working. We are not recommending the cold extrusion also, cold working. We have to see what it is. Cold extrusion is a process done at room temperature. Yes, we know this. Or slightly at elevated temperatures, not at hot, slightly. This process can be used for most materials which is subjected to designing of those materials. So robust enough tooling that can be withstand the stresses created by the extrusions. Examples for this cold working I am giving. For this cold working, example of the material that can be extruded are, see, lead, tin, very low melting point and very high in ductile nature at the room temperature itself. Leads, tins, aluminum alloys, copper, titanium, aluminum, vanadium steels, this having in ductile in nature. So therefore it is easy to compress. Example of parts that are cold extruded are, what are the examples I am giving? So collapsible tubes, somehow the aluminum cans, so that Pepsi, those cans can be normal room temperature can be extruded. The cylinders and the gear blankets can be done. What are the advantages here? We have seen in the hot working condition, when the material is at high temperature, it reacts with the environment, therefore it may form oxidations. Therefore that I have given here, it is a no oxidation treatment. It is a no oxidation treatment, and also good surface finish we are getting, and with the use of proper lubricants we can able to avoid those things of frictions, forces also. So rough surface will not form. Good mechanical properties. Why we are getting good mechanical properties? You see, here we have some grains like this. In a specimen. I am extruding or hot working or forging or rolling, or otherwise this extrusion process or pressing action takes place. What happens? This grains will be converted to the elongated flat nearby grains. It's converted into flat nearby grains because your pressing action is done. This round will be pressed, the grains will be pressed tightly. So like this it will be formed. Even though the grains are same, but here it is elongated and it is also tightly bonded at the same size. So what happens? We are finer grains we are getting, compressed grains we are getting, it means stronger grains we are forming there. The stronger grains creates the good strong mechanical property. Tensile strength we can increase. So good mechanical properties due to severe cold working as long as the temperature is created below the recrystallization temperature. After the recrystallization temperature only, these grains or microstructural changes will occur. For steel I am telling you 723. That is the critical temperature of steel. Likewise we can say less than that and there is no change in the microstructure. So that will help in the maintaining the mechanical properties. So some of the examples, like as cans, aluminum cans, and some of the tins we are manufacturing by the extrusion. This is a tube. For this, the die is in the round format. That is why it is coming like a can. If the die is different according to the design, it will come out. Hot extrusion process. What it is? Hot extrusion is done fairly at high temperatures. Approximately about 75% of the melting point. So for steel, we have already mentioned this point around 1000. For 1500 steel. The pressure scan ranges from 35 to 700 megapascal application of pressure we are doing. Force we have to give for extrusions. The most commonly used extrusion process is the hot direct extrusion process. What is direct method? We are pressing in one direction, on the same direction the product comes out. That is we are naming as a forward or direct extrusion process. The cross-sectional shape of the extrusion is defined by a shape of the die. The cross-section of this extrusion product is defined by the shape of the die. Die having the holes. Through the holes it is going to come out. Due to the high temperature and pressure and its detrimental effect on the die life, as well as it affects the die life also because it is absorbing the heat. Die is at ideal condition. Billet, the material which we want to extrude is at the red hot condition. It is going to face the die. It is going to face the normal room temperature die. Therefore, the temperature gradient will exchange the temperature from the billet to the die. Die is going to absorb the temperature, but it should withstand. Before it should not be readily deformable. It should not deform. If it is deformed, it will come out along with the billet on the holes. So those things, the die material to be picked out in such a way it withstands the high temperature materials. If you are using the aluminium, its melting point is 600. The hard working of 70% maybe 400 to 300. Therefore, the die can be steel, which will be at 1500, or titanium, which is having the more temperature of 3000. Such dies we should use. It should not affect this temperature transactions. So such things to be taken care. Cold extrusion and hot extrusion I am comparing now. We have already done the advantages, disadvantages of hot and cold workings, hot and cold forgings. Now hot and cold extrusion treatment. All points will be similar. It is done at room temperature. Yes, we know this hot and cold working is done at room temperature. Nearly room temperatures. It is fairly done at high temperatures. Maybe that is 0.57 times. What is that? Maybe 1100 per steel. So likewise, above the, but we should understand above the requisite temperature, what is it? Critical temperature is 723 for steel. So it's something we should remember. The advantage of this over hot extrusions are lack of oxidation, yes, higher strength, yes, due to cold working, closer tolerance. Yes, we know closer tolerance because with this not increasing, more force, we can able to maintain how much we should give the force to deform this 1 mm with increasing or decreasing. Better surface finish, yes, this point all comes for cold working, better surface finish. Similarly for hot extrusion, due to the high temperatures and the pressure and its detrimental effects on the die life also reduces. So with the same points we have seen now. It's a good lubricants that can be used to reduce the frictional contact between the die. Somehow lightly lubricants can be used at the corners near the die, such a way the friction can be reduced or contact or transfer of the temperature from the billet to the die can be reduced, so therefore the die life can be increased. So such things can be done. So some images I want to show you. These images belongs to this extrusions processes. Hot extrusions, typical part produced by extrusion, trimmed part used in the automotive industries for our applications. Example, aluminum extrusions are used in the commercial and the domestics buildings for the windows, doors, door frame systems, prefabricated houses. So you can remember. So this prefabricated houses are prepared for hospitality emergency wards. Immediately they will make a frames and they create the hospitals. So those things can be easily done by this aluminiums. We remember this. Building structures, roofings, exterior cladding operations, all things are done by this aluminium extrusions only. So very important. Now I am coming to the classification. As of now we have seen about the general frames of the extrusion process. Now I am coming to the classification of these extrusions. What is extrusions and what is hot extrusions, cold extrusions, some definitions we have seen. Now the remaining part of classifications you will see. I am dividing as like of the forging treatments, as like of rolling. Here also I can able to divide in terms of operating temperatures. What are they? The extrusion can be takes place at the hot extrusions. The extrusion can be takes place at the cold extrusions. This is one. And one more, by terms of equipment. I am fitting some equipments in the industries. In terms of horizontal setup, these extrusions we are sending here and we are pressing the billet, it should come out. Therefore, it may be the horizontal setup. Horizontal setup machine can be there in such a way it is horizontal, or otherwise it may be vertical also. I'm putting the billet at the top and I'm pressing from the top, and the billet or frames or product is coming down. It may be vertical also. The machine can be horizontal, machine can be vertical. So it is independent. So this is one type. I'm dividing the extrusion process in some terms. The terms may be temperature, the terms may be equipment. And the very important part, I am dividing the extrusion process in terms of directions. What is this? We have to see. This is important. This we know, hot and cold, up or down, horizontal, vertical, we know this. Here, the direct or forward extrusions, the indirect or backward extrusions we should see. It means when the material is putting in this direction and it is pressure over there, the product comes in the other end. We are putting in left end of the product, pressure, and it is forwarded, and the product comes in the right side, right end, other end. That is called as a forward. It is keep on going. But here in the indirect or backward extrusions, when the material is put here and we are pressing takes place in this direction, the material here will be the die, and it will impinge and it comes in the reverse format as a cup. Likewise, a tumbler you can take. So that all comes under the backward extrusion. The force applied on the same direction for force, the product comes is called as a forward extrusions. What is the force applied? The product comes opposite to that we are calling as a backward extrusions. One by one we will look over. The remaining part of the subjects we'll see you in the next class. Thank you.